Hi everyone, welcome to Maths with Shivanand Sir here. Let us learn an important concept today. A graph speaks many property. If you are in BSc or in engineering or in any mathematics era, so this concept is very important here. There is one beautiful saying in English here. A graph can speak many words here. A picture is worth 1,000 words here. So with the help of graph, by seeing the graph only, mathematically we can interpret n number of its property. It speaks completely how it is, why it is, what are all the property it will exhibit here. By seeing the graph only, we can exhibit many property here, especially for class 11 and class 12 students here. What are all the property we can explain with the help of graphs? Let us study today. So let us see. So we have the topic right from sets to what here differential equation in our syllabus here. So each and every property can be explained with the help of graph very easily. But in our syllabus, there is a lot of algebraic interpretation rather than a graphical approach here. But if you know the graph here, really your algebraical path will understand very easily here. Listen. So then let us start without wasting much time. So let me begin with the session today. What are all the property can be explained with the help of what here graph? The first thing is the domain. So what is the domain? What is the input of this function here? So any function we can study in many ways here. One is the algebraical way, other is what here graphical way. If you understood the graph, you will understand it the heart of the function here very easily. You know where all its property goes on here. So first character we can speak the domain. Domain nothing but what here input. So I have written a graph here. The graph is of y is equal to x cube. By seeing the graph only I can speak its domain here. What is the domain of this function? The domain nothing but what here the input here. Input always we give along what here x-axis. For this function here, what is the input here? So here we are giving the value along x-axis, positive x-axis also and negative x-axis also. So nothing but the domain of this function is what here? So along x-axis, right from minus infinity to what here? Plus infinity. Hence the domain of this function is what here? Minus infinity to what here? Plus infinity. Okay, I can say by seeing at the graph here. Then what is the range here? Range of this function is what here? Range is nothing but the output or its answer I can say. So range is so taken along what here? Y-axis here. So by seeing the graph only I can speak here. The graph is moving towards positive y-axis as well as towards what here? Negative y-axis. It is taking all the value right from minus infinity to what here? Plus infinity. The range of this function is also what here? Minus infinity to plus infinity. So each and every property I will explain clearly in the next video here. I'm just giving a small example for you in my next session. So I will take how to find domain and range. So in one video and two more I will break into two more session here and will explain clearly. So how do you find domain and range with the help of what here graph? Now I'm briefly introducing this concept here. Why the graph is very essential to learn here and the function here. So let us see y is equal to x cube is a function or not here. So to check whether it is a function or not here, we will do what here? So the vertical line test here. If you draw any vertical line here, if your line touches the curve at only one point, it is a function. If it touches at multiple point here, it is not a function. For example, you can take a circle here. So we can draw one vertical line here. So it will intersect at 2 points here. Hence circle is not a function here. To check so whether it is a function or not, we use what here? The vertical line test here. If you know its graph here, definitely you can say, so you can draw a vertical line here and check whether it is a function or not here. And so the third one, the fourth property, roots or zeros here. Roots nothing but so where your graph cuts x-axis here. Where your graph cuts axis, where the value of y is what here? 0. For example, y is equal to x cube. It cuts your graph at x equal to what here? 0. So nothing but it has what here? Only one real root. Cube nothing but I will exhibit more. So in the next in my next video here. So how do you find the roots here? By seeing the graph only, y only one root, cube nothing but there would be 3 roots here. Y only one root is appearing here. So nothing but the graph cuts only the graph cuts x-axis at only one point here. Where are 2 points here? Those 2 points are what here? The imaginary points here. Because of that they are not appearing here. Only one real root we are getting here. So roots. So for this real roots is what here? Only one root is appearing here. Roots are zeros. You can say here one root. And we can exhibit the property number 5. It's a class 12 concept which is very important. If you know only algebraic part here, you cannot interpret anything here. If you know the graph part here, increase and decrease function, maximum, minima, the complete application of differentiation is very easy for you. The complete calculus depends upon the graph. Without graph, we cannot understand any of the property here. Okay, increasing or decreasing function here. So y is equal to x cube function is whether it is increasing or decreasing here. So how do you check increasing or decreasing? We check its property right from left to here right. So from left to right, whether the function is increasing or decreasing here. So we'll exhibit more in the next video here. Say if I take right from 0 to, so this guy here, it's increasing, right? Again, from minus infinity to 0, again it is what here, increasing function here. Okay, so let us debate more on this in my next video here. So in property number 6 here, the maxima or what here, minima. So what is maxima or minima? So I am taking the curve of y is equal to x cube here. Say y is equal to x cube.
Y is equal to
so
x square.
Y is equal to x cube.
Y is equal to x
what is the maximum value and what is the minimum value? Maxima or minimum is nothing but f of x value. The minimum value of this function is what here, 0 minimum value. The maximum value, the curve goes towards infinity. The maximum value is what here, not defined. The minimum value is what here, 0. The maximum value is what here, not defined. If you know the graph, you can speak here. If you don't know the graph, you cannot speak anything here. So keep remember students here, the maxima or minima, it's one of the beautiful concept in mathematics here. And the seventh property, 1 function. So 1 or injective function we say. So it comes under relation function. Okay. So to check 1 or not here, we go with what here? We go with so the horizontal line test here. If your horizontal line touches the curve at only one point, so that function is 1 function. For every input there exists what here, one unique output here. So for example 1, so 1 with one more value here, say 1 comma y1. Say if it is a 2 point here, say it's a 2 comma what here, y2. So to check whether the function is 1 or not, easily we can speak with the help of graph. For this we are doing what here, horizontal line test here. For function we are going with what here, vertical line test here. Okay, so the next property is what here, even function or odd function here. So if the function is even, so I will say algebraically f of minus x is equal to f of x. It's a condition for even function here. So then f of minus x is equal to minus f of x. This is a condition for what here, odd function. So take an example of y is equal to what here, x square. Y is equal to x square. Okay, so this guy is what here, even function. I will say only a small example. So let us explore more clearly in my next session here. Okay, f of minus x is equal to nothing but, so I have a curve y is equal to x square here. Say f of x is equal to x square here. Okay, so if I give input f of minus x, then also it becomes what here, minus x square, nothing but x square. So nothing but f of minus x is equal to what here, f of x. Hence y is equal to x square is what kind of function here? It is a even function. Keep remember, it is even function here. Though you give the negative input here, your result is always what here, positive. So to check whether it is 1, so whether it is even or odd, we use the graph concept here. So keep remembering, if the function is even, it is always symmetrical about what here, y-axis. Nothing but it always takes what here, positive value only. So because of that, this guy is what here, even function. Y is equal to x cube is what kind of function? So if I give here f of minus x is equal to, sorry, if I take the function f of x is equal to x cube, and f of minus x is what here, minus x cube. Nothing but this guy is what here, odd function. F of x equal to x square is what kind of function here, even function. If it is even, it's symmetrical about what here, y-axis. We can speak here. By seeing the graph only, I can say whether it is a even or so odd function. Next property number 9 here, continuous or discontinuous function here. Check. So is it possible for you to draw this graph without lifting your pen here? If you draw this graph without lifting your pen, definitely it is continuous function here. So else it is not so continuous. We say discontinuous function here. So okay. So next property number 10, which is very important here, differentiable or not here. So it's a concept of what here, differentiability. If it is possible to differentiate, we'll start differentiating here. So keep remember students here, if the function is continuous, then we start differentiating. If the function is continuous, I can differentiate. I can. So it's not 100% case here. So listen here, y is equal to y is equal to this, y is equal to what here, mod x is a curve here. This function is continuous, right? Continuous, but it is not differentiable at x equal to 0. Why it is not differentiable? Because at x equal to 0, it's possible for me to draw more than one tangent. Multiple tangents are possible. Derivative is nothing but tangent. Tangent should be always what here? Unique. At x is equal to 0, I am getting here multiple tangents here. Hence, for this curve, it is not differentiable at x equal to 0, though it is continuous, but not derivative here. So by seeing the where all the function is derivative, not differentiable here, if we get the corner here, or the function is not differentiable at end point here, if you get a very sharp turn or the corner point, in such function, in such case, your function is what here? Not differentiable. Okay. I hope so. In brief, you understood why graph is very important here. Look at here. So the domain range function is a concept of set relation function here. It's a class 11. Increasing, decreasing, maxima, minima is again a concept of class 12. So and derivative is class 12 here. Even odd function and one function is the relation function here. Almost all around 50% of the concept have been covered here. If you understood the graph here, definitely things would be very easy here. For more questions in JW can easily answered with the help of here graph. So let us continue this session here. Okay, let it go. So start with the basic graphs here. What are all the basic graphs in mathematics here? What I need to understand perfectly here. So there are around 7 variety of Fourier graphs here. I need to understand its behavior here, how it moves here. So if I understood the behavior of those graphs here, I can interpret many graphs very easily. Okay. So now let us start with our basic graphs concept here. So graph number 1, it's a linear function here. Keep remember, whenever the word linear comes here, it is always in the form of what here? Straight line. Keep remember, it's what here? Straight line. So what f of x is equal to what here? The algebraic interpretation is what here? Ax plus b. So any system of equation in the form or any polynomial in the form f of x equal to ax plus b is always represents what here? A linear function. Keep remember, with the power degree equal to what here? 1. Okay, so linear function nothing but it's a straight line. So not maybe of this kind here. It's of the curve y is equal to mx plus c something here. It may be either a horizontal line or vertical line, or it might be might be like anything here. Linear nothing but which moves in a straight line. That is enough here. Second kind of function here, which is very important here, square function here. Square function is always of the category parabolic type here. Keep remember student here. So many students remember only the curve of y is equal to x square. So if I say y is equal to x square, they will interpret this graph here. If I say y is equal to x raised to 4, y is equal to x raised to 6, or y is equal to x raised to 10, it's not possible for them to draw here. So remember student here. So x raised to 4 I can write as x square of square here, x cube I can write here, x cube of square here. Also x raised 10 I can write x to the power of pi to the x raised to 5 to the power of what here 2. All curves are what here? Square function only. So x raised to 4 is also of this kind here. Remember, if somebody asks you to draw y is equal to x raised to 4, y is equal to x raised to 4, again it is the parabolic shape only. Okay, y is equal to x raised to 6, again it is this shape only. X is 10, so 11, 12. Y is equal to, keep remember, x to the power of what here? 2n. So is always what here? This shape only. Keep remember students here, when it belongs to integer. So square function, keep remember here, all square functions are of parabolic shape here. So all square functions are, keep remember, they are what kind of function? Even function, and they are symmetrical about y-axis here. So somebody has given the graph for you to test whether it is square function or not here. Somebody has mentioned this graph here. So what kind of function it is? It simply say, don't say y is equal to x square. So I never mentioned its value here. You simply say it's a square function. The reason is, so I am getting first point, the minimum point, minimum value is there, minimum. So, and one more is symmetrical about what here? Y-axis is there. So based on this hint here, we can say easily it's what here? Square function here. And so keep remember, I said here, so y is equal to x raised to 2n. So where n belongs to positive integer, always all kind of category comes under this parabolic shape only. So now property graph number 3 is a cube function here. Y is equal to x cube. Y is equal to x cube. It's a cube function, right? Okay, I said in my previous session here. Okay, so y is equal to x cube, or sometime y is equal to x raised to what here? Any odd curve. Say y is equal to x cube, or y is equal power of 2n plus 1, I can say 2n plus 1. Don't say is it one, sometime y is equal to f of x to x comes, it's a linear function here. I am saying 2n plus 1 here. So y is equal to x raised to 5, or y is equal to x raised to 7, y is equal to x raised to 9. Any kind would be of this shape only. Keep remember here, whenever, so y is equal to, somebody will tell you to draw y is equal to x raised to 5, definitely it is of this kind. X raised to 7, same category. X raised to 9, same. X raised to, so 1, x raised to 1 not 1, definitely of this category only. Keep remember students here. Okay. So now next property, so square root function here. Okay, we'll be having what here, we'll be going to what here, square root function. Okay, so the f of x equal to root x, this like what here, this guy, same like it's like little like exponential curve here. F of x is equal to what here, root x here. Okay, keep remember student here. So not only root x here, somebody asks you draw root 2x graph here, root 3x, root 5x, so root 6x, anything might be there of the word here, same shape only. Keep remember it's basic so shape here. So sometimes the question is of the type f of x is equal to f of root 2x is there, root 2x. Okay, whether it is 1 1 or not, so the question might be thing here. So to draw 1 1, we go with what here, so horizontal line test here. If so, definitely it passes, it cuts at only one point here, it's 1 1 here. So root 3x or root 5x, root 6x here. So all will be having the what here, the same format only. The appearance of the graph is what here, always same. Keep remember this function here, the square root function here, square root 2x, 3x, 4x, 5x, so any x here. So now graph number 5 here. So phi shape curve here, phi shape, one is equal to y is equal to x plus x, other is y is equal to minus x. It is having what here, two straight line, so at intersecting at one point here. This kind of graph we say what here, absolute value function, or what here, modulus function here. Okay, so it may be y is equal to mod 2x or mod 3x or mod 5x, mod 6x. Any mod function is always of the what here, phi shape category. Keep remember kids here. So now, so sixth one is what here, reciprocal function here, 1 upon x here. So y f of x is of the form what here, 1 by x. So all reciprocal function here, keep remember kids here. So all reciprocal function, 1 by x, 1 by 2x, 1 by 3x, 1 by 5x, even. So this kind of function always in this shape only. You will be having what here, two leaves here. It will keep remember here, I am drawing this kind of category here. It will never touch y-axis, and here it will never touch what here, x-axis. So here it never touch what here, y-axis. These are we say asymptotes. So they will never, so we say they will meet at infinity. Practically it is what here, impossible. So remember kids here, so straight line, a linear function, parabolic shape, a square function. So this kind of category is a little say type, if we say the q function. So it's a rocket of function is called what here, square root function, and the phi shape category we say what here, modulus function, and the reciprocal function. So you will be having what here, two leap. So you can draw 1 by 2x or 1 by 3x or 1 by 5x, anything can be of the same shape here. So we'll study lot many session on this graph part here, how to draw y is equal to f of x equal to 1 by x cube, x raised to 5. We'll see in my next session here. Okay. So we'll go with one more concept now. Property number 7. Sorry, graph number 7 is a logarithm function here. So it again what here? It's like this one only. It meets x-axis at the point what here, 1 comma 0. Why? So if I put x equal to 1, log 1 value is what here, is 0. Keep remember students here, it will not touch y-axis here. Y-axis is what here? It's an asymptote for log for here. So log 2x, log 3x, log 4x. So remember this what here, the basic result here, this shape only. Okay, so y is equal to e raised to x, both are what here, inverse to each other here. Y is equal to e raised to exponential function, again it cuts that point what here, 0 comma 1 here. So keep remember students here, this guy will never touch what here, x-axis here. So never touch x-axis. So how can you interpret here? If it never touch x-axis, nothing but it will never take the value of y equal to 0. Not possible. Why it's not possible here? So listen here. You can assign any value of x here. You can give any value, say any real number here. So for e to the power of x here. So it will never give the value equal to what here, 0. For no value of x, it will be 0 here. Definitely, you will not get. The curve will never intersect what here, x-axis here. So the x-axis is called about here, asymptotes here. So by seeing the graph only, we can speak what kind of category it is here. So it's exponential, it's what here, logarithm function here. So it is your favorite function, it's a sine curve, y is equal to sine x. You might have known many times here. So the sine function is plus 1, max value, mean value is what here, minus 1. What is the domain of sine function here? I can say a domain of some sine function. Your sine function is moving from here 0 to right infinity, 0 to minus infinity. The domain of this function is minus infinity to what here, plus infinity. The range of this function here, range nothing but your answer, your output. It's right going from minus 1 to what here, plus 1. The range of this function is what here, it's open interval, minus 1 to what here, so minus 1 to 1 here. But it is continuous or discontinuous? Definitely it is continuous. Okay, so it is possible for you to differentiate. So differentiation always occurs at a particular point here, so we'll exhibit later here. Okay, so y is equal to what here, sine x, the basic graph here. If you know sine x, you can interpret sine 2x, 3x, 4x, 5x, sine of x plus 1, something, sine x plus 1. Okay, and so the last one I'm going with what here, the greatest integer function. The greatest integer function, what is the domain here? Domain, I am assigning all the value right from minus infinity plus infinity. The domain is what here, real number. What is the range of this function? Range of this function is always what here, integer here. So this is a step like function here. Keep remember students here. So today we have learned so many graphs now. So keep remember all the graphs here. In my next session here, let me so discuss here how to find out so domain range function with the help of graph, how to find out roots with the help of graphs, and how to find out increasing, decreasing, or maximum minima. So by looking at the graph here. So hope you understand student here. If you like the video, so kindly share among your friends. It's time to congratulate the fastest finger for the question on limits part 9 video is Miss Pujanasi. I wish every student to answer very fastly. Whether it may be first or last year, do answer in the comment box here. Okay, your so sincere efforts matters a lot here. So dear students, let me have a small questions for you. So mention the type of graphs. Okay, so you need to identify what kind of graph they are, whether they are linear, square, square root, or so parabolic curve function here, log function, or exponential something here. So hope you understood the video students here. If you like the video, kindly share among your friends here. Every like will motivate for me to do so some awesome video for you. Okay, the PDF of this session is available in the comment box here. Download it here and do study well here. All the best for your JEE and KCET exam here. Bye bye. Take care.